Okay, we're now going to write generalized inspection equations for MOSFET amplifiers. Now we know that we have resistances tied to the drain, gate, and source of the MOSFET, RD, RG, and R $sign. Those are all capital letters. We have the intrinsic resistances looking into the device as R little g, R little d, and R little s. And these can be given by the following. We know that looking into the gate, we see an open circuit or infinite resistance. Looking into the source, we see approximately 1 over GM. And looking into the drain, we see RO times 1 plus GM times R $sign. We can now write the voltage gain for a CS common source, CG common gate, and CD common drain amplifier. The GM for a common source amplifier is GM times 1 plus GM, or divided by 1 plus GM times R $sign. The RT is R big D in parallel with R little d. For a common gate amplifier, it is just GM times R big D in parallel with R little d. And the common drain amplifier is GM divided by 1 plus GM times R $sign, and the total resistance is R $sign. We can do this also for a BJT. We have R big B, R sense sign, and RE as our extrinsic resistors. And we also can find the resistors looking into the terminals of the transistor, R little b, R little e, and R little c. R little b is equal to R pi plus 1 plus beta times RE, R big E. R little c is equal to RO times 1 plus GM times R big E. And R little e is approximately equal to 1 over GM. We can now use these to write expressions for voltage gain for the common emitter, CE, common base, CB, and common collector amplifiers. For the common emitter amplifier, it is AV is equal to R little b divided by R big B plus R little b times negative GM divided by 1 plus GM times big RE times the quantity RC in parallel with R sense sign. The common base it's R little e divided by R big E plus R little e times GM times RC in parallel with R sense sign. And finally, for the common collector, it is R little b divided by RB plus R little b times GM divided by 1 plus GM times R big E times RE. In this case, this is our big GM, this is our big RT, and we have a voltage division at the input. Now, every time we see any of these 6 amplifier topologies, we know that the voltage gain is going to be similar. So all that we have to do is find the external resistors that are tied to the collector, base, and emitter for the BJT amplifiers, and the drain, gate, and source for the MOS amplifiers, and then substitute them into these formulas, and we will know the voltage gain without having to do small signal analysis. So we're going to stop there for today, and we will talk to you in the next lecture.